All right, amigos. So in the previous video, we installed the GCC compiler on Windows. Then we wrote our very first C program using Notepad. Yes, good old Notepad. And compiled and ran it using the command prompt. Now I know what you might be thinking. Are we really going to code like this forever? No, I made you do that for a reason. Because I didn't want you just to click a button and magically see the output. I wanted you to understand what actually happens when you compile a program. What compilation actually means, how your C code turns into something the computer can understand. That step was important, but now we're upgrading. In this video, we're going to set things up properly. We'll move to a better environment where writing code feels smoother, faster, and honestly, a lot less painful. This is where programming starts feeling real. So let's get into it. We're going to use Visual Studio Code, or VS Code, as our code editor. Just to be clear, VS Code is not a compiler. GCC is still doing the compilation in the background. VS Code is just going to make our lives easier. It gives us a clean interface, proper file management, syntax highlighting, extensions, and the ability to run our programs without typing long commands every single time. First, download and install VS Code. Yes, it's that simple. Now, let's take a good look at the whole interface. Not just this one. In general, whenever you install any software tool, it's a good idea to go through the interface once and just familiarize yourself with it to see what tools are available and what buttons are there. Understand roughly what each section does. You don't need to invest too much time trying to memorize everything. That's not necessary. As you keep using the software, you'll automatically get comfortable with it and slowly gain expertise. But in the beginning, having a rough overview really helps. So when you first open VS Code after installation, you'll probably see something like release notes, showing what new updates they have introduced in the latest version. Now at the top, just like most software tools, you'll see options like File, Edit, Selection, View, and so on. Under File, you can create new files, open existing files or folders, save your work, and do other basic but important operations. Make sure autosave is enabled. That way, you don't have to worry too much about forgetting to press Ctrl+S. Then under Edit, you'll find the usual options like undo, redo, copy, paste, and so on. Most of these shortcuts are already familiar to us. Anyway, if you want a complete reference, you can go to the Help option here at the top and click on Keyboard Shortcuts Reference. It will open a PDF in your browser listing all the shortcuts you need. You can download it and keep it for reference. Now, another important functionality that we use very frequently in VS Code is executing the program. After all, the purpose of writing any program is to execute it, right? In VS Code, you have two options here. Start debugging and run without debugging. For now, at the beginner stage, especially for simple C programs, we will mostly use run without debugging. You can press Ctrl+F5 to do that. When you press that, VS Code will first compile your program using GCC and then execute the generated file. Even though it feels like a single action, internally it is still compiling first and then running. Now, let's talk about debugging, because I skipped explaining it in our previous video. Debugging is simply the process of finding and fixing errors in your code. Testing tells you that something is wrong, whereas debugging helps you figure out why it is wrong and how to fix it. To assist with this process, we use something called a debugger. Just like we installed the GCC compiler earlier, we also need to install a debugger separately. VS Code does not come with a C compiler or debugger built in. Since we are using MSYS2 with the UCRT64 toolchain, we can install the debugger by running the following command inside the MSYS2 UCRT64 terminal. This installs GDB in the same folder where GCC is installed. Because we already added that folder to our system environment variables earlier, we do not need to add the path again. So now VS Code can access both the C compiler and the debugger from the same toolchain. Before we start coding C in VS Code, we need to install a couple of extensions. You just need to go to the extensions panel here on the left, search for C/C++, and install the one provided by Microsoft. Make sure it's from Microsoft. This extension gives us proper IntelliSense, error detection while typing, debugging integration, and overall language support for C and C++. Next, search for Code Runner and install it as well. Well, Code Runner allows us to quickly run our program with a simple click. It's especially useful in the beginning when we just want to test small programs quickly. Now, you might also notice extensions like GitHub Copilot or tools related to AI coding assistance. These are powerful tools that can suggest code, explain errors, and even help you write logic faster. They usually require subscription or access through services like ChatGPT+. We won't depend on them for learning fundamentals, but once you understand the basics, these tools can become very powerful assistants. For now, let's focus on building our own understanding first. Okay, so after installing Code Runner, we need to adjust a few small settings. Go to File, Preferences, Settings. In the search bar, type Code Runner. You'll see a few options. First, enable the option that clears previous output before each run. This keeps your output clean and prevents confusion when running programs multiple times. Then scroll down a little. Enable these options. These small settings prevent very common beginner mistakes, like running an old version of your code because you forgot to save it. Trust me, that happens more often than you think. Once these are enabled, your environment is much smoother to work with. But before we continue, let me clarify something. There are proper IDEs available for C and C++. IDE stands for Integrated Development Environment, and as the name suggests, everything is integrated. You install the IDE, and it usually comes with a compiler setup, debugger integration, project management tools, and many other things already configured for you. You don't have to separately install the compiler. You don't have to manually install the debugger. You don't have to configure paths. You just start coding. So then the obvious question is, why are we going through all this setup in VS Code? Because VS Code follows a different philosophy. VS Code is not a heavy, all-in-one IDE by default. It is a lightweight code editor. And through extensions, we gradually add the features we need. In a way, we are building our own IDE. We install the compiler we prefer. We install the debugger we prefer. We install the extensions we need. Nothing more, nothing less. And this flexibility is one of the reasons many professionals prefer VS Code. Another important reason is multi-language support. Suppose tomorrow you want to write Python, or JavaScript, or work with web development. You don't need to install a completely different, heavy IDE and learn a completely new environment. You stay in the same editor, you just install the relevant extension, you already know where the buttons are, you already know how the interface works, you don't have to mentally switch environments. And honestly, switching tools is harder than people think. Most people don't like switching. VS Code solves that by becoming a common environment for many languages. It is also lightweight compared to many full IDEs. It starts fast, feels responsive, and does not consume unnecessary resources. So yes, the initial setup for C/C++ may feel like a hassle. But once it is done, you have a flexible, powerful environment that you can use for almost any language. Now, let's create a folder on the desktop to organize all the C programs that we are going to write in this course. Let's name it C_programs. Why the underscore? Honestly, it's just a habit of mine. You could name it C programs with a space as well. That's completely fine. Inside this folder, let's create our first C program. In the previous video, we already wrote the classic Hello World program when we tested the compiler using Notepad and the command prompt. So this time, let's try something slightly more interesting. Let's write a program that asks the user for two numbers and calculates their average. So here, we're declaring two variables that will hold the numbers entered by the user. Let me pause here for a moment. In C, we usually write everything inside functions. What exactly is a function? A function is basically a block of code that performs a specific task. Instead of writing everything randomly, we organize our code into these small blocks so that it's easier to understand and manage. You can think of a function like a small machine. You give it some input, it does some work, and it gives you an output. Now, among all the functions, there is one special function called main. You'll see it in every C program. This is where the execution of the program begins. When you run your program, the system starts executing from the main function. So basically, every C program must have one main function. I hope you got it. Now, what we have here at the top of the code is something called a preprocessor directive. You don't need to worry too much about the term right now. Just understand what it does. This line tells the compiler to include something called a header file. In this case, it's stdio.h. This header file contains definitions for functions like printf and scanf that we are using in our program. These are built-in functions in C that we use very frequently. Printf is used to display output on the screen for the user to read, and scanf is used to take input from the user through the keyboard. Now, if we don't include this line, the compiler won't understand what these functions mean, and it will result in an error. We'll understand preprocessor directives in more detail later. For now, just remember this. Whenever you are using input and output functions like printf and scanf, you need to include stdio.h. Got it? Now, let's resume with the code. Look at this. You can see we are getting suggestions for the next probable lines of code. That's because of the extension called GitHub Copilot. Pretty cool, right? So whenever you see a suggestion that matches what you want, you can just press tab to auto-complete it. Features like this are just there to assist us. They may not always give exactly what we need. At the end of the day, we should understand what we are writing and shape the code according to our requirements. Now let's run the program. Okay, let me enter 8 and 12. Yeah, that's correct. The average is 10. Nice. Our first program in VS Code. Kinda cool, right? Once again, we'll run the code, and this time, let's enter 38.7 and 89.46. Before we press enter, let's quickly estimate the answer. It should be 64.08. Let's check that. Yes, that's exactly what we got. It's cool, isn't it?